hopefully all of you are familiar with it. Just go to professional development, roundtables, and there we are as MetroNorth. Today's talk will be on integrating Six Sigma and project management. I'd like to introduce Arun, who's a project manager specializing in IT process improvement and IT system integration projects. He holds an MBA degree in general management and currently holds both PMP and Prince 2 practitioner project management certifications. With that, I'm going to disconnect and turn it over to Arun. Try function F8 again. Bingo.
Morning. Did someone just join?
Good try, though.
So, thank you very much for joining us here. So basically, how it started off is I was preparing for Six Sigma Black Belt last year, and actually I achieved it as well. I'm a Six Sigma Black Belt as well right now. So it started off as a fun hobby to try to connect between Prince 2, PMP, and when I started preparing for Six Sigma, I was wondering how to, as a project manager, how to integrate with the PMP structure which we have, which is set by the standard set by the PMO office, or how to introduce the Six Sigma concept into a company which is already following some framework, the project management framework in their own way. How to make it a little bit flexible so that they can be used by the project manager in a most effective way. So when I first was given with the task with the Six Sigma project, I was a little bit confused with what the Six Sigma Black Belt do and what as a project manager I have to do. So the first project, it was a failure. So there was a problem because I didn't understand Six Sigma much properly, what I have to know, and the Six Sigma Black Belt played a role of a project manager than actually what the Black Belt has to do. So that was the issue which I faced in the first two projects. And after I went through training in Six Sigma and preparing for the Black Belt, I got a better idea how to integrate that with the project management. In the project management, what we follow in every project, I don't know how many of you are following the agile practices right now. In Resource System, we always follow the waterfall model. And Resource System is a product-based company. So the Six Sigma becomes the most important factor which will drive the products to the market faster with a better quality so that the customers will be more satisfied than how they are right now. So that's basically how it started this project. That's basically how I figured out, okay, let's put something together so that the fellow project managers don't have to follow my steps. They can succeed even in their first project, which they're taking, Six Sigma project, which they are going to take. So the first question we wanted to ask ourselves is, what mean by quality? From a perspective, what we know that they desire as a quality. So, for example, let's take, when you're buying a phone, what is the quality which you're looking for? For example, let's start with.
I want reliability, always to work.
Okay. So, which functionality? All the functionality, or what functionality do you desire?
Well, obviously just the phone functionality. You want that to work. You usually want your display to work. Clear, concise information that you can receive over the phone.
Okay. So, what do you think as a quality?
I don't want it to be buggy. I want it to do what I want it to do, not what it wants to do.
So,
straight to signal. Sure.
Okay. Stay with the application or
Usually accessing the internet.
okay.
Just speed applications, but primarily accessing the internet and then accessing different programs, sending text.
Okay.
Screen size.
Screen size.
LD.
I'm with these guys, strength of signal, that it actually works, and, dials reliably.
So we never talk about the cost. No one cares about the cost.
Well, that's not quality, right?
No, the cost and the quality has some difference. Right. So that's how everyone has their own preference. That's how they divide the market segments into several segments, and they target their product into particular segments, not everyone. There are certain qualities which everyone likes to have. For example, the reliability, the speed with which they connect, and the application is opening up faster. So those things are the ones which Six Sigma concentrates. How we can get those critical quality which will drive the sales of a particular product. So that's basically what the Six Sigma tries to improve in an existing product. One catch with the Six Sigma project is that the Six Sigma project cannot be applied to the new project or developing a new product. It always applies to the existing process which is already there and improve it. So the existing process, can it be applied to any existing process? No, it cannot be applied to any existing process. The existing process will be a well-established one which is running under a control. If I say a call center call pickup, a person picks up and calls up within 300 minutes, if I say that that is the process which I am having right now, we say that it should always be within that limit. If it is not within that limit, there is some problem with the process, and we need to identify what is that problem. For example, they tell in the Six Sigma 2 causes for a particular problem, 2 causes for a delay, 2 causes for a defect. The one is a common cause, the other is a special cause. What is a common cause? Common cause is actually because of the process, some bottleneck in the process. Whereas the special cause is caused by, for example, the operator of a machine is not properly trained. That's why the problem is happening, or some external factor which cannot be controlled by anyone in the management or anyone in the floor working out. Any developers can control. So those are the special causes. So Six Sigma doesn't try to solve those special causes. It concentrates only on the common causes.
I just want to double check that one. It's important. So if I understand it correctly, a common cause is a problem within the process. Special cause is not within the process, is some other thing.
Something else which is exterior to the process.
Gotcha.
Someone, for example, in the software development, a developer's talent is an exterior input into the process, right?
Right.
Those things the Six Sigma doesn't solve. It has to be solved by the HR or giving additional training. It is separate separate problem which has to be handled by some other players, not the Six Sigma project team. So before we go through that, the Six Sigma process and the way of thinking in a Six Sigma, we will just try to, I just stole something from you, John, to the risk. So let's try to solve this problem. Increasing the survival rate of a bomber, which is used in World War II. So this is the requirement. The military has hired all of us to decide what we need to do to increase the bomber survival rate so that they will come back alive and reach the base, US base. So how do you approach that problem? You can ask anything, any questions, what is the approach? So what will be the first approach? What will be the first step? As a project manager, don't think about in the Six Sigma way.
Find out what's causing them not to survive.
Right. Because
It's pretty obvious, right? The enemy shoots like a fly, so.
Well, is it enemy fire? Is it the fact that they run out of gas? Is it the fact that...
Okay, let's say it's because of the enemy.
okay.
And so are they flying high enough? So it's like, you're,
They are flying as much as they have to fly to attack a target.
and can they fly higher? And is that one of the solutions in order to,
Okay, let's say they cannot fly higher.
they cannot fly higher? Okay.
Are they able to evade enemy fire?
Right, rather maneuverable.
They try as much as possible, but not completely.
Maybe more stealthy.
They are attacking the enemy target directly, so
Do they need more guns so they can shoot enemy planes?
it's already have a lot of guns. If you're adding more guns, it will be so heavy that it cannot fly faster.
You're talking about survival rate. You're talking about
Going, attacking a target, and returning back to the base.
and returning back to the base. So you're saying you want to increase the probability that they will return back to base safely,
Right.
not ejecting.
Not eject, not
Not
eject,
eject.
not eject.
Okay.
So how do you make them able to survive more hits?
Right.
So
For that, what do you need? What do we need?
want to improve the quality of the plane. This
And
It's the maximum quality possible at that time.
maximum quality possible.
Terry,
That
these
is
are
tactics.
With respect to the material, I mean.
Yeah, then it's tactics and skills, in terms of flying skills, more.
Enola
Anything
Gay
else?
made it home. The plane that dropped the nuclear bomb on.
Right. It's a, nukes everywhere. Have to go. Can't respond.
So any other data you need?
Yeah, what are the dangers in flying back, other than, there's one, how do you sustain damage? I'm assuming, and see, that's a big assumption, I'm assuming they've sustained damage, correct or not correct?
No,
Okay,
they are not able to.
so,
They are not able to sustain the damage.
Well,
So
then they need to be better able to sustain damage.
how do we do that?
What are the pieces that most often fail? Is it where the wings connect to the bomber? Is it that engines fail?
But the flight which already went down is went down. We don't have the sample size. So how we can analyze that case?
Analyze it when they get back, the ones that did get back.
Okay, we have it.
Yeah. What's true of the planes that survived?
here we go, and we have, that's the
We
data.
have the data.
Right. That's my next guess.
So based upon this is the bullet holes mapped on an actual plane. Based upon what they see in the actual plane, which return back after striking the enemy target. So what can we do to improve this survival rate?
Do we have any, can I ask for additional data?
Yeah,
Do we have data on those that did not make it back? Have we recovered any of those wreckage?
If you're risking, you can go and check.
Well, the damage inflicted by each of those spots, what made it survive because of that, and, what could be the most damaging resulting from those bullets.
Right, what are the critical spots that, if it were hit, it would bring it down or prevent it from traveling that far of a distance back?
Okay. So let's say we decide on improving the armor little bit better in a spot where you think it is critical to increase the several parts. So which are the parts you think we have to improve the armor?
Inside wingspan for sure.
Well, getting hit on the wingspan didn't seem to make a difference, but where the wings connect to the fuselage.
Right. And the flaps on the rear, I would say, would make a big difference. You gotta put some redundancy in there or something.
Well, wherever we see holes, that shows that's something the plane can survive already.
Right.
So it's where don't we see holes that
Cockpit.
well, two engines were hit on this one.
Yeah, but, that's one hit. If you had multiple hits, what would be the damage? I mean, you clearly don't see multiple hits on any of the engines.
Let's say even if the one dot, which means the engine is damaged.
Well, you've got your redundancy with the 4 engines, so they were able to fly back with 2 engines already.
There aren't many hits on the forward. In fact, there are no hits forward, cockpit and forward. There's one on the side, so that may be an area to strengthen.
So what we can conclude is this area, and this area is not hit by the enemy fire, made the the planes returning back to the base, right? So if we can concentrate on improving the armor of this cockpit and at least 2 of the engine, it will survive back. So what we can conclude is increasing the armor in the 4 engines and the cockpit area solves the purpose. It will increase the survival rate, right? You are getting the point, right? This is the one which survived. So it survived because it didn't get hit in the cockpit area and at least 2 of it. That's why it flew back. So we have to increase armor only in those areas. We don't have to build an armor for the entire wing or the entire body. If you are doing so, what happens is it becomes heavy and it is going to hurt even more survival rate. So this is basically how we have to think when you are forming a Six Sigma project team. So let's take a step back and we see what the Six Sigma is. So everyone is familiar with this sigma symbol in the mathematics. So what does that sigma signify? What sigma means in mathematics?
I think it's the deviation from the mean from.
The deviation from the mean. So if I say sigma value is 5, given certain number, what does that signify?
So it's, you've got deviation on both sides of the mean, 5 deviations to the left, 5 deviations to the right, it's a range
Okay.
across that.
So 10, for example, if I say 10 is the mean, 5 is the standard deviation. So what you are saying is the values, the number data will be falling anywhere between 15 to 5, right?
That's right. Right. Within that range. Yep.
Within that range.
Yes.
Somewhere between that range.
Correct.
All the numbers.
And we're getting more accurate the wider we go. We're going from 68% to 99-something percent.
Right. So that's basically what they develop as a metric. So if I say a particular machine is going to produce a table of height, for example, a table of height, I don't know, maybe 5 meters, something, a big table, I don't know what the 5 meter is. So let's say a ladder of height, 10 feet high. So if I say a process which is producing that ladder is going to produce with the sigma level of 5, with the sigma level of 12, which means 10 feet high is the actual one, and 2 feet is the standard deviation. So whatever the ladder which is going to be produced by that machine is going to be between 12 and 8. So based upon the mathematical calculation and doing the regression analysis, what they found is if you say the process is 1 sigma level, which means these many number of parts is going to be fall outside that range. So if I say a 10 feet ladder, my process is sigma level 1, which means I'm going to produce only 68.27% within that range. The other percentage will be maybe more or less. So if a customer says, I want a ladder of height 10 feet, the maximum is allowed is 12 and the minimum allowed is 8. If I have this process, almost 30% of my product is not going to be accepted by the customer, right? So that's why they made the calculation and they found that 6 sigma is the range which my process has to be within the specification limits produced by the customer. It has to be in this range. If it is in this range, only 0.02002% of my product is going to fail, which means only 3.4 ladders is going to fail in a million ladders I am going to produce on the product. So this is what we can use sigma as a metric. So if you say 6 sigma, which if you are trying to achieve 6 sigma, we can say the process is going to be more and more accurate in producing what is meant to be produced. So if we can control the process, we don't have to spend time on prevention costs, or we don't have to spend time on the failure, external and internal failure costs. So that's basically what the Six Sigma is trying to achieve. So Six Sigma as a philosophy. Why we have to consider Six Sigma as a philosophy is, if as a project manager, I alone think that the Six Sigma has to be implemented and the process has to be done, whatever the process, whatever the method I'm going to follow, it has to be based upon the Six Sigma. Not only I have to think in that way. the entire project team has to think in that way. If they don't think in that perspective, what happens is someone somewhere, they just neglect certain points, neglect certain process, neglect certain activity which is done in the process, and it is going to hurt the entire the project. So that's why the Six Sigma will be successful if it is taught as a philosophy, if it is everyone in the project team thinks in the Six Sigma way. So in the old belief is that if you need high quality, the cost should be high, the quality cost especially. So if you think a particular phone is selling at $150 and another phone is selling at $80, it doesn't mean the phone which is selling at $100 is better quality than the phone selling at $80, right? And if the features is almost the same, I'm going to buy the $80 phone rather than a $100 phone. So this was the old belief. If you want high quality, you have to spend more money. But the Six Sigma taught the other way. You don't have to spend too much in the external cost, internal failure cost and external failure cost, and you don't have to spend too much in the prevention cost. If we can improve your current process and move it from whatever the level of Sigma level it is in. For example, if I move from 4 Sigma level, my process to 5 Sigma level or process to 6 Sigma level, I will get a better quality with lower cost. That's what the Six Sigma tries to prove. So, which is a good one? Which level is a good one? So, if you say that your process is in the 3.5, 4 range, that's basically what we are trying to achieve. That is the most possible level to achieve. So, but we still try to reach the Six Sigma level, but none of the company has done so far. They follow and try to improve. This is a continuous process. They try to improve the process again and again, trying to reach the Six Sigma level. But if you have reached 3.5 to 4 Sigma level, then your process is good. If it is below 3.5 Sigma level, which means the process, something is terribly wrong with the process, and we have to change the process, or we have to do what is causing the issue, and we have to fix it right away.
And what is DPMO again?
DPMO is defect per million opportunity.
Okay, got it.
So, for example, if I have a pen, and I say, if for every pen, there is a chance of 2 defects. And if I have a laptop, and I will say, for every laptop I produce, there is a chance of 2 defects. So, is that 2 process is in the same Sigma level? No, because the laptop has a lot of opportunity to go wrong. It has a lot of components, a lot of integration is going to need to be there, but pen is a simple one. So, that's why to compare that processes, which is producing based upon the complexity, we have to have a common ground to understand where the Six Sigma process is lying in which Six Sigma level the process is lying in. So that's why we always talk with terms of defect per million opportunity, not the number of defects which is possible in a process, because it becomes what you call partiality, right? Because one is a simple component and the other one is a complex product. So what we try to achieve in Six Sigma, there are 2 cases in which the process will fall. The first case, if you see, whatever is produced from the process is falling close enough, right? But it is not on the target. The customer wants 10 feet ladder, but I am producing everything which is above 10 feet, right? So in this, the process in this condition, what we have to do is we have to center the specification of a process and make it towards the center. So here what they say is they have a high potential defect because everything is lying in the left side, and there is a chance a lot of defect is going to occur, even if it is in a Six Sigma level, even if it is in a 4 Sigma level, right? So these kind of a process, we need to try to center that and make it more accurate. The precision is there, the accuracy is not there. So here, this is the type of a process where we cannot use Six Sigma to improve, because here it's all dispersed. It's not in the control, it's not precise, it's not accurate. So these are the processes which cannot be solved using a Six Sigma method. This is what we try to achieve. All the products which is being produced by the process is falling in the center, following the mean, and the spread is across the mean. So the mean matches the hours mean, and it is within the specification. So there is two things we have to think about in this graph. One is upper and lower specification limit. This is what is set by the customer. For the process itself, they will have their own limits, right? That is called control limit, upper control limit and the lower control limit. So to improve the process, we need to make sure the upper control limit and the lower control limit of a process is going to be within the range of a
Question. I thought the upper and lower specification limits were the customer, and the upper and lower control limits were the process.
for the process.
That's true?
Yes.
Okay.
So in the normal curve, which is whatever the product is being produced, it is produced at 10 feet is the mean. Higher should be 12 feet, and the lower should be 8 feet, right? So this is the specification limit which is given by the customer. I told you the customer wants in this size range. So the process itself, which is the machine which is going to produce this product, they will have some limit, right? So that is called control limit, upper control limit and lower control limit. So if the upper control limit and the lower control limit of a process, if it is within this, which means the machine is not going to produce anything outside this limit, right? So that any product which is coming out of that machine is not going to be rejected because of poor quality from the customer. That's what we are trying to achieve in this.
Arun, what's CPA?
Is the capability, the process capability index. So we are not talking this in this meeting because it's more for a black belt to consider how to calculate the capacity limit and those stuff. As a project manager, we don't have to think in that perspective. As a project manager, we need to know what is that, but we don't need to know in-depth knowledge of what it is. So this is the most famous Sigma process method which we follow to improve the process. There is something else called a TFSS, designed for Six Sigma. The design for Six Sigma is to create a new process in a Six Sigma way. So that is not the scope of this presentation. We are going to follow what we do in the TMAC process, TMAIC. So let's go back to the flight scenario, which we talked earlier, right? So first thing what we try to do is what we do in defined case of the Six Sigma. We try to identify and state the problem. Why there is a less survival rate? What is the possibility? What is causing it? So those things is the activity of the define phase in the Six Sigma. The next is the measure phase. The measure phase is that we found that available data and we try to measure, okay, based upon this data, right? What is the points which is being hit? What is the points which is not being hit? And we try to analyze it. So in the analyze phase, what we found, okay, the two of the engines is not damaged, the cockpit part is not hit. That's why the flight is returned back. That's what is the analyze phase. The phase in the analyze phase, we do that in the Six Sigma project. The next is the improve phase. The improve phase, okay, these are the points which we think based upon the analysis is not hit, which made the flight to fly back to the US base. So which means we have to improve that particular piece armor in those areas. So that's the decision which is made in the improve phase, and then we are going to implement in the improve phase. The last piece is the control phase. In the control phase, what we are doing, we are going to make the change to the flight and test it, the pilot test it. Send them to the enemy target, try to see if the survival rate has increased. That's what is done in the control phase. It doesn't, the Six Sigma process, it doesn't stop in the control phase. It iterates. After it is solved, we are going back to the define phase and see if there is another problem which can be improved to make the survival rate. Again, we will measure something else, and then we will define, analyze, and then we will improve it again. It's a continuous improvement process. That's how the Six Sigma rolls. So what is the objective of define? To identify what needs to be improved in a project. If it is a development project, what we are trying to improve. Are we trying to improve the usability? Are we trying to improve the reliability? That's what we have to define first. What needs to be improved? Based upon what needs to be improved, we have to find what the customer thinks of that quality. If it is a mandatory quality, a critical quality which customer wants, the ease of use, the critical quality, then I have to concentrate on that particular quality. And then we need to define this is what we are going to work on in the Six Sigma project. The next is, based upon that, we need to identify who are the process owners. We have to form the project team. We have to create a project charter. We have to get approval from the senior management to go forward for the. So those are the responsibilities which, as a project manager, we have to do. Most important one is the.
It sounds like this process maps very closely to the idea of creating a minimum viable product by focusing on those things that you think are going to matter and enable people to try and use your product.
Right. It's not concentrating on the product. It's concentrating on what has to be improved in the product. It's already it's an existing product. So we already have a process in place.
Okay.
So if you're designing a new process or a new product, that's a different matter. It's DFS.
Okay.
So most important step as a project manager, I have to concentrate on VOC. VOC stands for voice of the customer, to collect what they want, and then they transform into a critical to quality tree. Based upon the critical to quality tree, we have to identify the finalized set of quality which needs to be improved in a particular product. Next, then we will scope out the project, and we will have the improvement plan. The improvement plan comes from the Six Sigma Black Belt. We don't have to form the improvement plan. The scope of the project, we have to finalize the scope of the project. We have to own that. Key team members and resource for the project. The entire thing has to be taken by us. We have to form the WBS structure. We have to produce the RPS structure, resource breakdown structure, the calendar we have to establish, the plan we have to establish. That's what we do in this defined phase. What we basically do in the project initiation phase and the project planning phase. Creating a plan, WBS structure, all those things can combine. So we can split the defined phase into two phases of the project manager PMP, which is project initiation and the project plan. The critical milestone stakeholder review, we have to follow it every now and then in the Six Sigma project. If we miss anything, we have to be very prompt in communicating that to the team, and we have to improve the chances of success. So end of every stage, every phase of a Six Sigma, we have to have a critical milestone. We have to set, if we are reaching, then it's fine, then we'll have a stakeholder review. If we're not reaching, then we have to go back and replan, have a team meeting and discuss what we have to do next. If we have to make a change management, if we have to go to the change management, we have to follow a change management plan and then proceed with whether to have a go or no go decision from the senior management. And then the most important step during the end of the defined step is, based upon all this input, we have to come out with the budget. So this is basically what, as a project manager, I do in my project. So here, in the method phase, is the phase in Six Sigma where the project manager doesn't have much deliverables. All these things, whatever the activity in the measure phase, is done by the black belt. So what they do is, the black belt ensure whatever the measurement system they are going to measure a quality is the appropriate one. If they say, I'm going to measure the ladder's height, I'm going to measure it with a tape, I have to make sure the tape, whatever is used, is up to the standard and it is appropriate system to be used. Those things is to be checked by the Six Sigma Black Belt. The next is prepared data collection plan. So this is the most important document which a black belt has to produce during the measure phase. If they don't produce, the project manager should make sure that he produces it by the end of the measure. If he doesn't produce, the Six Sigma project shouldn't go ahead into a analyze phase. This is the most important document from the black belt. The last one is the actual collection of data from the process. Here, who all involved is the process owner who is running the process currently in the business, and the Six Sigma black belt, green belt, and the technical person who is working within that process. They try to collect the data as much as possible, not all the data, just a sampling of it. So what needs to be sampled, what is the right sample size, all those things is decided by the Six Sigma black belt. So in matter phase, not much for the project manager to deliver.
Before you get off of that, can you give an example of the type of data they might be collecting? I'm trying to envision that. Just one instance from your own experience.
Just for example, in the Abraham Walls case, the missing bullet case.
Yeah.
So what we are trying to collect is, we try to collect each bullet point, right?
Yeah.
We thought, okay, the survival rate, we have to look at it.
Years ago?
That's the kind of a data they need to collect in that project. For project, if I wanted to process to reduce the number of defects going into the production, then I have to collect, okay, for each software or each functionality delivered to the business or to the end customers, how many defects are there and why it is happening. So is it because of a number of lines, or is it the complexity? Based upon that feature, we have to make sure what kind of the data has to be. So it varies from project to project. If it is a call center, we have to check, okay, why the call center call is exceeding 300 minutes for a particular case, right? It's because of the common cause or the special cause. Is it because of the process? Because whoever picks up the call center call is not the person who is going to solve the problem which the end customer is talking about. So is it a problem with the communication, or is it a problem with the person who is taking the call, first call up, or is it the system? So those kind of things it depends upon the project. The data collection is based upon what kind of a project we are looking at and what kind of a process we are trying to improve.
Excellent.
So anything else?
The people who are black belts, they typically have a statisticians or the software do it all for them. They have to be really well-rounded in statistics to do this?
Right. Right.
Okay.
So they have to be a statistical pro. They need to know the advanced statistics, hypothesis. They have to know the regression analysis, whatever. I'm not very good at that, but
I got you.
somehow I got the black belt. Next stage is the analyze stage. So based upon the data, we need to analyze what we need to focus on to improve. So in our case, the armor, to improve the armor on the engine and the cockpit is the output from the analyze. So in this, the process analysis document will be the one which is produced by the black belt. The brainstorm, the root causes, which will be the meeting run by the project manager to bring all the Six Sigma project team together to understand what is the root causes based upon the Pareto diagrams and based upon the root cause analysis diagram, fishbone diagram. So based upon that, the brainstorming session needs to be conducted by the project manager.
Okay. Got something here too. In your earlier slide, you were talking about how Six Sigma can actually be used to reduce costs. That plain example was, one possible solution was to armor the entire plane. That would add cost in terms of material and fuel. So what they want to do is, okay, we want to be able to protect the plane, but keep the cost down.
Right.
So the solution was just to reinforce those areas that were wrong. That's a big cost.
Right, and also not to reduce the speed as well.
Right.
So overall, the quality is also reducing if we add the armor to the entire plane. So the developing the hypothesis is, for example, if a particular feature in the product is defect is caused because of one particular event, activity happening in the process. So we need to make a link, right? For that, what they do is there are several causes for that particular failure to happen. A defect can go into a software, the final software product, because of a code written by the user, right? Or it's because of the business requirement. It's a stating that, or some problem with the project management process itself, right? So those things, what they do is the black belt, they will try to form an experiment kind of a stuff. They will design an experiment and test. Okay, if the developer does this bug 1 wanted, knowingly he does include a bug in a code and he will test how the process goes. If it is identified by the QA team, then it is fine. If they are not identifying, then the problem is not the bug returned by the developer. I would concentrate on improving the QA team's performance on the process and what are the process steps.
It occurs to me that Six Sigma isn't going to work well with a small team because you won't have statistically relevant data.
Right.
You need a large enough team and a large enough project to be generating enough data to analyze with any confidence.
It also depends. That's why the black belt 2 is for improving a particular process. What is the sample size? The sample size needed to be analyzed more, then I need a more bigger team to statistically analyze. The sample size required to meet the need is less, and I don't have to. It depends upon the variation in the process. If the variation is too high, the sample size needs to be high to be confident enough to say that improving this will improve the quality. So it really depends upon the sample size.
The one thing I do remember from statistics class, that sample size has to be at least 35 points.
35?
35 test points to be significant. That's the only thing I remember from that class.
So it depends upon. I don't know what you mean by the 35 points. So
Data points. If you have fewer than 35 data points,
significant.
then it's statistically insignificant.
That seems pretty low. Yeah, I'm not.
Yeah,
Real low.
which it sounds low to me, but
I'm not sure, but there is a calculation to calculate the sample size.
Well, if you have a sample size less than that, your level of significant data you receive from that is unreliable.
Mm-hmm.
Be at least minimum 35.
So it depends upon you're talking about the sample points. I'm talking about for example, when I am.
a survey
Mm-hmm.
of questionnaire,
Mm-hmm.
you need at least 35 responses back in order to make it a significant reading. Viability of the data.
I really
Ever read that?
No.
The only thing I do know from that class.
So I remember.
well, you guys probably needed to
Yeah,
share class
yeah.
notes and then
That's right.
together.
I learned it long time back in 2000.
Just want to know, we have less than 10 minutes.
Okay. So most important we need to
5 minutes.
Okay, so I think we discuss more on the analyze phase. Let's go to the improve phase. Improve phase, what they need to do is they map the improved process and they compare it with the existing process, how it is different, what kind of a change a particular person has to do, what activity has changed. So those they map out, and then finally a pilot solution is put to use, and they measure at several interval points. Like it depends upon the process again. Sometimes they do it every 3 months. They check back if it's going well, the pilot solution, before making it the actual business as usual process. And the last one is identifying the operating tolerance. How much we are okay to sacrifice. For example, if we say that we should be 99% sure that this pilot process has to be works properly, or we should be 95% if it is okay, and we are good. So it depends upon that. We have to do more analysis or making a more design of experiment upon the operating tolerance. So back to your sampling size. The sampling size is basically based upon what significance level you want the hypothesis to be. If the control interval, the hypothesis, if it has to be the confidence interval level is 95%, then the sample size might be a smaller one. If you want it to be 99%, it should be larger. It really depends upon that. So in Six Sigma also they have alpha risk and the beta risk. Alpha risk is what the customer faces. The beta risk is what the product producer faces. So depending upon the alpha is the control interval level, which we talked in the statistical class. So in the improve phase, the top portion of the slide is done by the black belt. They do analyze the problem, they find the root cause, they provide the solution, the alternative problems, and then they will find what are the things which is causing the problem. Again, alternate solutions they produce. Finally, they run the design of experiment steps, collect the data, run the hypothesis, and finally come out with what we need to be done. And as a project manager, we need to do the cost and benefit analysis. For the solution which they will provide, like for example, they come out with 3 solutions, right? We have to find which is the best solution to be selected, which as a project manager we have to run the cost benefit analysis. We will be tracking the earned value of the project, how it is going to track the health of the project, and then analysis, then of experiment analysis. Using the pilot solution, finally we will prepare the plan how to run the batch. And every 3 months we need to check back on the pilot solution before making it as a business as usual.
When does, if it's the black felt, I get that result, do I run to you, do I say it for a lessons learned meeting, does it give the project, when does that?
So usually, in the project what we do is we have a weekly status meeting, and then also we follow up based upon the deadline. If there is a deadline of someone, we go and have a one-to-one meeting as soon as the deadline comes up. We'll give a heads up a couple of days back if it is still on the deadline or if it is going to be moved a little bit further. Based upon that, we will have one-on-one. And usually what they do is we have a tool in the software system called Perform tool. Have you heard about the 3D experience platform and Perform tool? We have our own tool, the project tracking tool, online tool cloud solution. So as soon as someone finishes the work, you'll get an alert and the results will be there attached to that. And as soon as that is done, one person completes it, it will automatically notify to the other person who is in line waiting for something from that particular task. So it's automated basically. So one-on-one meeting we usually have to discuss any issues, but otherwise we skip the meeting. And we have a weekly status meeting every week. So control phase, this is the most tricky part in the project management on a Six Sigma project. So how long do you want to make sure that the pilot solution is running fine? So that's the thing which a project manager and senior management has to decide, right? If it is running for 3 months, what happens is sometimes when something is new to a particular process, a person who is doing that particular activity change will be more careful, right? We try to make the best. After some time, we kind of, get laid back and we say, okay, this is fine, it's working fine, no one is going to keep an eye on us and it's going to be how it is going to fall back or how it is going to be kept on that particular process. We have to monitor. So this is the most tricky part which the project manager has to do extra than his actual duty. So process control plan is an additional document which the project manager has to produce in the project. Monitoring and response plan is also something additional. When they monitor what are the control points which need to be completed, all those things we have to have it as a plan, an additional document. The last one is the storyboard during the review. So these are the additional documents which I think every project manager in a Six Sigma project has to do, additional to what they actually have in their other projects to be successful in Six Sigma projects. So in simple terms, map the process, identify that X factor which is driving the quality, measure that process to identify what is causing that, what is controlling that X factor. Based upon that, we will form a statistical notation or formula based upon the statistical analysis, and that's pretty much what they do as a black belt in Six Sigma process. So this is an overview of what we have learned. Define phase, starter, and the business case we develop. Mapping existing processes coming from the black belt and collecting voice of the customer and the requirement gathering is how we are going to map the PMP, the project initiation, and all those processes with this deliverable. So define phase is spread across the project initiation phase and the project planning phase. And the Method CTQ's requirements is what is done in the execution phase in the PMP, right? That's what the actual execution of the project is. That's the core activity of the project is. Determine the process stability, process capability, all those things. Process stability is the precision, how it is running, whether it is producing the consistent result or it is spread. The process capability is how much the capability. Finally, the closing the project has to be done at the end of the control phase once everything is done in the pilot solution. So I had one more slide which I thought is the most important, but so
This, we'll put the slides up on,
so only thing I wanted to talk about is the FMEA, the failure mode effort analysis. For each cause in a each defect in a particular product, there is a failure mode in the process which is causing that. That's what they design in the FMEA. The other one I want to talk about is the UOE, design of experiment, which I already gave a little bit during our slide. And then I think pretty much it.
thank you.
You mentioned upfront a Six Sigma project. Is that what that is, or is it just project teams within an organization that support Six Sigma? Or are they designated as?
So Six Sigma project team, what I mean is black belt and the green belt, working along with the project team who is involved in that process. For example, as a developer, I'm not a Six Sigma project team.
Right, okay.
So I will be a project team in general, but Six Sigma project team is the black belt and the green belt who is going to work with me to understand what the process I am involved in, what activity I do in the software development.
Do you think that the teams find it worthwhile, or they like to guide and or they feel crushed by the weight of all those documents and processes?
So, in my personal experience, TISA system is also has introduced like a year back, so it's not completely understood by everyone. That's why the training is the most important part. So whenever we start the Six Sigma project, we train the developers because it's a software product. The end product is software product. So the software developers and the managers who is running the project development activities, they need to be trained as well.